Now let us discuss the torque on a current loop in a uniform magnetic field. We know what is torque, that is rotational analog of force. First consider a loop PQRS is placed in a magnetic field, carry current I. Now the force on arm PQ is I PQ, that is the length of this arm, cross B. Here this PQ is along y-axis, magnetic field is along x-axis, so we can write for this force F1 equal to I LJ cap cross BI cap, and this value will be ILB minus K cap. Similarly, the force on arm QR is IQR cross B. This will be ILB I cross I, because both in the same direction, and its value will be 0. Again the force F3 on arm RS, that is I RS cross B, and this value will be ILB K cap. Again the force on R SP, that will be 0. Here the wire, current carrying wire, which is either along the direction of B or against the direction of B, experiences no force. But see, the arm PQ and RS experiences equal but opposite force, and we know equal and opposite force acting on different line of action constitute a couple, and the torque of this couple is either force into perpendicular distance. So it will be either force is ILB into perpendicular distance between these two R, that is PS. So this will be ILBB. L and B is the area, L into B, so it is IAB, where A is the area of the loop. For N turns, this torque will be NIAB. Remember, IA is a magnetic moment. Torque is a vector quantity, so in vector form we can write torque equal to N times of M cross B. Now here, on the basis of this discussion, a problem. 100 turns closely wound circular coil of radius 10 cm carries a current of 3.2 ampere. What is the magnetic field at the center of the coil? What is the magnetic moment of this coil? Here given N equal to 100, R equal to 10 cm, it is 0.1 meter, and current I is 3.2 ampere. We know the magnetic field at the center of circular coil is B equal to mu naught Ni by 2R. So on substituting the value, that is mu naught equal to 4 pi into 10 to the power minus 7, N equal to 100, and I equal to 3.2 by 2 into 0.1. Its value will be 64 pi into 10 to the power minus 5 Tesla. So the magnetic moment, total magnetic moment, that is NIA. It is Ni pi r square. If we multiply here Remember 3.2 into pi is 10, nearly it is 10. So if we remember this value pi into 3.2, we can directly substitute 10. If not, then its value will be 10.100 into 3.2 into 3.14 into 0.01. It will be 10.04 ampere meter square, which is the SI unit of magnetic moment. Another problem, the same one here, circular coil of 100 turns of radius 10 centimeter carries a current of 3.2 ampere, is placed in vertical plane and is free to rotate about a horizontal axis which coincides with its diameter. A uniform magnetic field of 2 Tesla in the horizontal direction exists such that initially the axis of the coil is in the direction of the field. The coil rotates through an angle of 90 degrees under the influence of magnetic field. What is the torque on the coil in initial and final position? What is the angular speed acquired by the coil when it has rotated by 90 degrees? The moment of inertia of the coil is 0.1 kg meter square. See its solution, try at your own. But here solution is given, you can verify from this one. Thank you.